S. Okay? The object is stuck on this circle, it's moving along the circle. So the distance is just the length of arc along the circle. Yay uzunluğu, length of arc. Okay? Now you see, as the object moves, as theta becomes larger, this length will also increase. In fact, you can see that the length of arc is proportional to S is proportional to theta. Okay, as the object moves along, theta increases, and the distance it travels on the circle increases in direct proportion to theta. Is this clear? Now, if my object is moving on this circle, it will move a certain distance for theta equals 30 degrees, okay, so much. If it is moving on a larger circle, for the same theta, it will move a longer distance. So the distance gone is also proportional to the size of the circle. How much is the distance gone? Well, it depends on the units of r, s, and theta. Okay, so there is some constant in front, and the value of the constant depends on your definition of the units. Okay? Constant times r times theta. This is absolutely clear to everyone. Now, yes or no? Any questions? Okay, I'm asking you a question. Do you understand what I just said? Yes or no? Okay, I'm saying the following. If an object moves along a circle, the distance it goes is proportional to the angle.
The angle of
the angle, no, of course. The distance it goes, it starts from here, it comes up to here. So it goes a distance, and at the same time, its angle has changed. The change in the angle and the distance gone are proportional to each other. But if this object is moving in a bigger circle, for the same angle, it will go a larger distance. So the distance gone is also proportional to the size of the circle. So I put there the radius of the circle. Proportional means there's also a constant in front, and the constant depends on the units you use. Okay? Clear? This constant depends on units. For example, if theta is in degrees, let's find the constant. Theta equals 360 degrees. Okay? If I start from here, and my object turns by a full circle, comes back, and if I'm measuring the angle theta in your usual degree units, the angle is 360 degrees. What is S in that case? It is the full circle. Okay? So, S equals 2 pi r equals this constant times r times 360 degrees. Okay? So the constant is 2 pi over 360 degrees. Right? That's your formula for distance if your units of angle are degrees. The distance will be then, the distance gun will be 2 pi over 360 times r times theta. If theta is 45 degrees, you put 45 and you put 2 pi over 360, and that gives you the distance in meters. The distance traveled along the circle, right? So we use our knowledge of geometry and the formula for the full circle in terms of the radius to fix what the constant is when the angle is 360 degrees for the full circle. Okay. Now I'm going to define a new kind of unit. Because 360 degree is a human unit, is a traditional unit. It is not a very convenient mathematical unit. Why do I have 360 degrees? Where does it come from for the full circle? Where do you think it comes from?
Total amount of
That is what it is. But why did people historically choose a unit so that the full turnaround has the numerical value of 360? So what's special about 360?
what years?
Right. If you look at our surroundings, how we make a calendar and how we measure angles of things that turn around in the sky, okay? A full turn of the Earth around the Sun is 365 days, close to 360. A turn of the Moon around the Earth is 28 days, which is close to 30. And the number of months in a year is not exactly but close to 12. So that is the reason why historically people thought the number 12 and its multiples and 360, 60, 30, these things are used. Okay? But that is not a basic fundamental concept of nature or of mathematics. It's just a human convention. Now let's look at the situation from the point of view of simplicity. I want S equals some constant times R times theta. Okay, break for a moment. Okay? So I know just from geometry that S equals some constant times R times theta. And with our usual degree units, that value of the constant is 2 pi over 360. Now to make life simple, let us choose some other unit for degree such that that constant is simple. What is the simplest constant I can put there? Kaç koyayım oraya? 10. Somebody says 10. Somebody says 4. What is the simplest number to multiply with? 1, of course. So I put 1. If you multiply by 0, you don't get anything out of this. It's useless. Choose unit of theta such that the constant is 1. Okay? S equals r theta, and that unit is called the radian. So r is in meters, S is in meters, and theta is in radians, and the constant of proportionality is 1. Okay, that defines a different unit of angle, right? Well, how big is that angle? Now let us figure out the conversion between our new radian unit and the old unit of degrees. Again, for a full circle, S equals 2 pi r, but at the same time equals r times theta in radians. So this says full circle equals 2 pi radians, but it also equals 360 degrees. So 1 radian is 360 degrees over 2 pi. Pi is a bit larger than 3. So a radian is a bit smaller than 60 degrees. 60 degrees is an angle like that. So a radian is something like 57 degrees, something like that. That's how big a radian is. Okay? Is this clear? You all understand our motivation for defining this radian, just to get rid of this constant. So this is the natural mathematical unit of angle. Okay? Any questions?